Welcome back everyone for Daily LeetCode Live. So let's get started. So today's question is check if array is sorted and rotated. So let's see what it wants. Given an array nums, return true if the array was originally sorted in non-decreasing order. So it should be increasing, but it allows the same number next to each other. Then rotated some number of positions. Otherwise, return false. There may be duplicates in the original array. Let's see what it wants. I see. So, when it say rotate, that means, so let's get here. So 3, 4, 5, 1, 2 works because if you think about it as a circle, we can start at 1 and then it goes back, and then it goes like 3, 4, 5. So something like this, and this is sorted. So that'll work, but 2, 1, 3, 4 does not work. Well, because if you put it in a circle, there's no starting point that can make this array non-decreasing, sorted in non-decreasing order. So, well, the first instinct is we have to find the smallest number. But what happens when you have, let's say, 2 ones? So what if it is 1, 1, 2, 3? Well, we should always start at the earliest one. So, yeah, I think so. The algorithm would be, we have an array. So let's say like 2, 3, 1, 1. We find the minimum, and we remember the leftmost smallest one. So, we get this one instead of this one, and then we just check whether it is sorted in, well, non-decreasing order, and the algorithm is the algorithm is ON, and what is our size? Well, it's only 100, so it'll definitely work. So first of all, let's get the length of the array, and then we want to find the minimum. And its index. So min element. Well, all the numbers are from 1 to 100. So let's just well, the nicest way is definitely to use float infinity because nothing is bigger than that. And then we also want the index. So we can start at 0. Actually, we can always start with a valid number. So the first element in the array will always be valid. Like, we just don't want to set like something like -1 that like the number is smaller than like all the other number, or maybe like 70, but like the whole array is full of like numbers bigger than 90, then like we will have an error by then. Yep. So for I in range n, actually we should do for x in nums, but then we want to get the index as well, so that's why we enumerate it. So if x is strictly smaller, because if it is equal, we don't actually want that number. If it is strictly smaller, we want that to be x, and then the minimum index should be I. So now we should start it there. So range n, well, we want to Well, basically, we want to check if every number, like if every pair of number from from the minimum index is, well, non-decreasing. So uh well, but this is going to loop from 0 to n minus 1, so we have to offset it with minimum index. So we can do something like well, we can get the minimum index, so um, it will be, sorry, let me get this thing back. Yeah, nice. Yeah, so this is going to be minimum index, and we want to check from that point on. So that'll be plus 0, that'll be plus 1. So actually we only have n minus 1 pairs, so so we should actually do n minus 1 here. So min index, and then the next thing should be plus 1, but then we have to offset it with I. So where it is 0, it will be, well, like from the minimum index to the one next to it. But then it is also circular, so we want to modulo it. And that should loop us back. And we just want to check if it is bigger or equal. Well, actually, if it is not, so if it is strictly smaller, well, we can just return false. Otherwise, we can return true. Yeah, I think that works. Oh, what did I do wrong? Minimum index. What boo-boo did I do? Did they all return? Wait, this returned true? So you should check this pair though. So, Alright, so 4, 3. So if this is 4, the last one would be 3. So minimum index is 1. So 1 plus 1 plus 3. That will be 5. Wait, actually no. N is 4, so that's 3. So the biggest I is 2. So we have 2 there, and then we have 2, 1, minimum index is 1, so we have 4 here, modulo 4, so that would be the last element. And oh, oops, alright. Oh, what did I do wrong again? Oh, sorry. I see. Yeah, honestly, like when I'm writing it, I realized that my way is definitely not the cleanest. The cleanest would be just checking all the pairs, and uh, you can only have one pair that is non-decreasing. If every other pair is non-decreasing, then it will work. So yeah, why don't we just do that? That would be so much cleaner actually. So for I in range, n minus 1, because we want to look at the pairs. We also want a found what should we call it? Found decreasing pair. So when we find the decreasing pair, we should turn that to true, and then if we find another one, then it shouldn't work. Oh wait, but it is circular. Yeah, actually, the circular might make it a tiny bit different. So we have 2, 1, 3, 4. So this pair is fine, this is fine, that's not fine, and that's not fine. So yeah, actually we do have to check all the pairs. Oh, yep. And we can just use modulo at the end to loop back through. So so if nums I plus 1 is, so if nums I, well, if it is bigger, then and not found decreasing pair, we should just make that true. Maybe we'll put it in here. So if found decreasing pair, we want to return false. Otherwise, found decreasing pair should be true. We will turn it to true, and then if it passes, like if it doesn't fall into here, then it will be true. But then we also have to account for the last one, because the last one would be, well, it will be n minus 1 plus 1, so that will be n, and that's out of bounds. It should work. Yeah, surely. Yeah, nice. I'll see you tomorrow.